Hello everyone, welcome to this video. In this video we are going to study how to calculate limit of a function. We will look at different types of functions and we will study some basic methodology to calculate the limit of those functions. Limits of some functions can be found by simple substitution. Let us see some examples to understand that. So here we have the first question. Limit of x square minus 3x plus 4 as x is approaching 1. So we can see that x square minus 3x plus 4 is a polynomial function. As it is a quadratic function, we can see that. And how to calculate this function using substitution? Now the methodology here of substitution is wherever you have x, you just substitute the value of x as 1. So here we will get 1 square minus 3 times 1 plus 4. And when we simplify this, we will get the value as 2. So we can see that limit of this polynomial function as x is approaching 1 is 2. Let us look at another example. Limit of x cube plus 5 whole divided by x minus 1 as x is approaching 3. Here again we will try to substitute x as 3. We will get 3 cube plus 5 divided by 3 minus 1. And one thing you should observe is that the moment I substituted x as 3, I have not written this limit x is approaching 3 part. So the moment you apply the limit, you should drop that limit extending to 3 part. So here you will get 3 cube as 27 plus 5 divided by 2. We know that 27 plus 5 is 32 and 32 divided by 2 is 16. So we observed now two examples of functions where limit can be found by simple substitution of the value for x. Let us have a look at another example where we will find that simple substitution will yield a result which cannot be considered as a limit. So let us see that example. So here we have limit of the function x square minus 3x plus 2 whole divided by x square minus x minus 2, and x is approaching 2. So when we try to substitute x is 2 here, we will get 2 square minus 3 times 2 plus 2 whole divided by 2 square minus 2 minus 2. We observe that 2 square is 4 minus 6 plus 2 divided by 4 minus 2 minus 2. What we observe in the numerator and denominator is that the values are 0 and 0. So we get 0 divided by 0, and we call this form as an indeterminate form. When we studied limits, this is called an indeterminate form. So when we apply limits by substitution, we may get forms like this. There are some other indeterminate forms as well, like infinity by infinity, 0 times infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, and 1 to the power infinity. These are some of the common indeterminate forms which you get when you try to substitute the value for x. Now in such cases, what you have to do? You have to proceed further in a different manner. So here in the same problem, what I'm going to do is I'm going to factorize the numerator and denominator. So when you try to factorize the numerator and denominator, we can see both the numerators and denominator is a quadratic function. So how we can factorize the numerator and denominator? I'm going to use the middle term splitting method or the factorization method, and I'll get the numerator as x square minus 2x minus x plus 2 divided by x square minus 2x plus x minus 2. And after factorization, I'll get limit as x tending to 2 I'll get it as x minus 2 times x minus 1 divided by x minus 2 times x plus 1. Now at this stage I can see that in the numerator and in the denominator there is a common factor of x minus 2, and I can cancel these common factors because x is not equal to 2, x is just approaching to 2. So I'm not cancelling the zeros out, I'm cancelling a common factor which is close to 0. So that is alright for us. So we can cancel the common factors, and after cancelling, if I apply the limit in place of x here and in place of x here, I'll get 2 minus 1 divided by 2 plus 1, which gives me the value of the limit as 1 by 3. Let us look at another example to understand this little more. Here in this question we have limit of x to the power 2 minus 9 divided by x minus 3, and x is approaching 3 in the domain. We can see that when we try to substitute for x is 3, we will get 3 square, which is 9 minus 9 in the numerator, and that will give 0, and in the denominator it is 3 minus 3, which is again 0. So when we try to substitute, we will get a 0 by 0 form, and that is an indeterminate form. So we will try to factorize this. So we know that limit x approaching to 3, x square minus 9 can be written as x square minus 3 square divided by x minus 3, and the numerator can be factorized by using the difference of squares identity. So we will get it as x minus 3 times x plus 3 and the whole divided by x minus 3. Here again we can see that we can cancel the x minus 3 factors, and after applying the limits we will get 3 plus 3. We'll put 3 in place of this x. I'll get 3 plus 3, which is equal to 6. So we observed that when substitution is not giving us a determinate form, we need to factorize it and cancel out the common factors and then try to substitute the value, and then at that moment we get the answer. Now this may not be true for all problems or all types of functions. We will look at some type of functions where this will not work out. So let's have a look at this problem. We have here limit as x is approaching to 0, 2 minus x, the function is square root of 2 minus x minus square root of 2 plus x whole divided by x. Now in this case, if we try to substitute for x everywhere as 0, we will get the numerator as square root of 2 minus square root of 2, which is 0, and in the denominator it will be 0. So it is, when we try to substitute, it is 0 by 0 form. And this function is such that we cannot factorize it as such as well using any other identity or any method. So the only thing which you can do here is by multiplying the numerator and denominator with the conjugate of the numerator. So the conjugate of the numerator here is square root of 2 minus x plus square root of 2 plus x, and we will multiply the numerator and the denominator with the same value. After multiplying the numerator with the conjugates, we can use the a minus b times a plus b identity, and we will get the difference of squares in the numerator. So difference of squares there means square root of 2 minus x whole square minus square root of 2 plus x whole square, and that is in the numerator. And in the denominator we will get x times square root of 2 minus x plus square root of 2 plus x. When we try to simplify the numerator, we will get 2 minus x. The square root and the square will cancel each out, and the other one we will get it as minus 2 minus x divided by x times square root of 2 minus x plus square root of 2 plus x. So here we can see that this plus 2 and this negative 2 will get cancelled each other, and we are left with limit x approaching to 0. Negative x becomes negative 2 times x, and in the denominator you have x times square root of 2 minus x plus square root of 2 plus x. At this stage you can see there are common factors of x in the numerator and denominator, and I can cancel x because x is not equal to 0 but x is approaching to 0. So in this way I can cancel both x's in the numerator and denominator. And now at this stage, if I try to substitute the value of x as 0, I'll get negative 2 divided by square root of 2 minus 0 plus square root of 2 plus 0. So I'm left with negative 2 divided by square root of 2 plus square root of 2, which is negative 2 divided by 2 root 2. And I can cancel the 2's and the 2's here, and I'll end up with the answer as negative 1 by root 2. So the limit of this function is negative 1 by root 2. Let us look at another example to understand this little more. So we have the question here, limit square root of x plus 3 minus 2 divided by x minus 1, and x is approaching 1 in the domain. Again we will try to substitute, and when you try to substitute you will end up with 0 by 0 form, and you cannot factorize it in any other way as well. So we will try to multiply the numerator and the denominator with the conjugate. So here the conjugate of the numerator will be square root of x plus 3 plus 2, and we will multiply the denominator as well, x minus 1 times square root of x plus 3 plus 2. And in the numerator, as we have done before in the previous question, we will end up with the difference of squares identity. So we will have square root of x plus 3 whole square minus 2 square divided by x minus 1 times square root of x plus 3 plus 2. Now at this stage we will have limit x tending to 1. Square root of x plus 3 whole square, the square root and the square will cancel out each other. So we will end up with x plus 3 minus 4. And in the denominator we have x minus 1 times square root of x plus 3 plus 2. We can see that in the numerator when we try to simplify, we will end up with x minus 1. So we got x minus 1 as a factor in the numerator and in the denominator. So we can cancel out those x minus 1 factors. And at this stage, we will try to substitute the x value as 1. So we will end up with 1 divided by square root of 1 plus 3 plus 2, which will yield as 1 divided by square root of 4 plus 2. Now we know that square root of 4 is 2, so we will have 1 by 2 plus 2, which is equal to 1 by 4. So we have observed in these few examples that how substitution gives us the value of a limit, and when substitution fails to give us that means we will end up with an indeterminate form. We will try to factorize the numerator and denominator and cancel out the common factors and then try to substitute. So the main idea is to substitute back even after cancelling out the common factors. So this is what we looked in this video, where we understood how basic substitution helps us finding the limit of a function at a certain value of x in the domain, and also we understood how factorization helps us and the rationalization helps us in finding the limit of a function. So so in the next video we will try to use some standard limits formulae to calculate the limit of certain functions, and that will help us understanding of limits a little more. So thank you everyone. See you soon.